Yeah. All right, right triangle trigonometry. So far we've been using trigonometry to find these missing sides in triangles. If you're missing two sides of a right triangle, how do you find the third side? Yeah? What? Nice and loud. What? Nice and loud.
Pythagorean theorem.
That's better. Pythagorean theorem. We also learned that if there's similar right triangles, maybe there's some other ways to find some missing sides. We know the special triangles, how to find missing sides. Well, what if I don't have two missing sides? I only know one side of the triangle, but I also know an angle. And that's where our right triangle trigonometry can help us. So what is trigonometry? So you can find missing side lengths if you have two other side lengths using Pythagorean theorem. And you can also use some of these special triangles, special right triangles. But what if you have a right triangle and you know a side and an angle and you want to find another side length? So other things we can do with trigonometry is if you know two sides, but you want to find an angle. So today we're mostly working with this, and next class we'll work with this one. So trigonometry to the rescue. And I do have one of my favorite videos, so let's see if we can pick any of this up. So we were looking at that. Okay, what is trigonometry? It's a Greek word, and it means measurement of triangles. So there's the metry, the measures a trigon, right? Three sides. So measures of triangles. So it's based on ratios. Just give me a second, okay? I'll get your question in just a moment, okay? So it's based on the ratios of sides in a right triangle and how these ratios relate to the angles. So this is a right triangle. So it's all relative to an angle. So if I am interested in this angle, and we're only talking about the non-right angle, either A or C, acute angles, we look at the side lengths that are either opposite or adjacent. So I think we know what opposite means. What is adjacent? It says it right there. What does adjacent mean? Yes, sir. Abby? Next to, thank you. So if I'm looking at angle A, first of all, I like to identify my hypotenuse. I know it's that way. Opposite, right? It's on the other side. Adjacent is next to it. It touches it. So here's my adjacent side. Here's my opposite side. Here's my hypotenuse. Real quick, Amanda, yeah?
Trigonometry sounds.
Okay. So what different side ratios can we make relative to angle A? So what's a ratio? Something to something. So like I can say an opposite compared to a hypotenuse. I can measure those lengths. I can make a ratio. I can do adjacent compared to hypotenuse. What are other ratios I can make with these three different measurements? Give me one. Somebody.
The what? Oh.
I gave you two ratios. We can come up with more, right?
Yeah.
Based on these three things? Yeah, what's another one, Amanda?
How about adjacent over opposite?
Yes, we can certainly do that. What else? I think there's three more we can do. Does it? Oh, you must speak loud in this. I don't know. I don't know how to make you talk loud. What else? There's two more. Yeah?
Opposite over or
Opposite.
opposite over hypotenuse.
I got that one. But what's another way?
Hypotenuse over opposite.
Awesome. And then what's the last one then?
Hypotenuse over opposite.
Right? So there's really 6 different ratios we can come up with. These are trigonometric ratios. This is what they are. That's it. That's what they are. So we are only actually going to use 3 of those in this class. When you take trigonometry, you have choices. You can take Algebra 2 with trigonometry, or you can take trigonometry after that through calculus. You're going to learn about the other ones. But sine is opposite over hypotenuse, that particular ratio. So here's my angle. If you take that ratio, we call it the sine of that angle. If you take the adjacent over the hypotenuse, we call that cosine. And if you take the opposite over the adjacent, we call that tangent. Huh? I guess. I don't know where they come from. If you were to do hypotenuse over opposite, that is cosecant. If you do hypotenuse over adjacent, that's secant. And if you do adjacent over opposite, that's called cotangent. So we are not going to be worrying about those 3. You can really do everything you need with these guys. There's a mnemonic aid that they used in that video. They said, "Sokotoa, don't you know us?" Something like that, right? So SOHCAHTOA is a way to help you remember what the different ratios are. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent, opposite over adjacent. SOHCAHTOA. If you can remember that's just strange sounding mnemonic, you can remember what the different ratios are. Another thing is there's different ways of naming angles. So let's say this was triangle ABC. So you can say I want the sine of angle A. You can say I want the sine of angle CAB or BAC. But you can also use Greek letters in here. A very popular one to use is theta. And you saw that in the video as well. That's a theta. This is an alpha. This is a beta. You may see other Greek letters within these angles. And we just say, okay, angle theta. What's the sine of theta? So you'll see that a lot. It's like right here. Sine theta, cosine theta, tangent theta. Just a Greek letter. Okay. Trigonometric ratios. SOHCAHTOA. The sine of A is the side opposite angle A over the hypotenuse. Cosine, adjacent to angle A over hypotenuse. And tangent is the opposite of angle A over the adjacent. So this table gives the ratios relative to A. Now what if I want to know about C? So I would label these sides different. It's adjacent. AB is adjacent to angle A, but what is it relative to C? Opposite. Okay? This side, if I'm talking about angle A, it's opposite. But relative to angle C, it's the adjacent. So it changes based on what angle you're looking at. So what is the sine of C? I'm doing here. Oh. So this is side A, this is side B, this is side C. So what is the sine of C? Opposite over hypotenuse. C over B. What's the cosine of C? Adjacent over hypotenuse. A over B. The tangent of C is opposite over adjacent. Opposite over adjacent. C over A. That's how we would find those values. One thing I think that may not be obvious, naming convention. So in that triangle ABC, if we want to give a little shorthand name for this side, we name it after its opposite angle but in lowercase. So this side would be side A because it's opposite angle A. This side we would call a lowercase side B because it's opposite angle B. This side would be lowercase because it's opposite C. It's just a naming convention. So if I want the different ratios, if I'm working with C, that's the opposite, that's the adjacent, that's the hypotenuse. Opposite over hypotenuse, C over B, that would be your side. And so we'll do this with numbers, I think, coming up shortly to see, how this kind of works. Here's with numbers. So this one, I think on your paper, the X is not visible. So you see this on your paper, it's kind of the middle of page 1. There should be an X up here, and I think it got covered by that other figure. So you might want to put an X there, you know what I'm talking about? You find that figure on your paper? Yeah, put an X there. So I'm looking at sine of X. So when I'm working with X, I like to label what I know. First of all, which side is the hypotenuse? That's the easiest one to start with. Which one? Huh? Right, so there's my hypotenuse. I'm going to label that. Relative to X, this angle, which side is opposite? And relative to this angle, which side is adjacent? Amanda?
First side is 7.
Good. Now once you've kind of labeled this, then you just have to remember SOHCAHTOA. So if I want the ratio of sine of X, I'm going to do opposite over hypotenuse, sine of X is 24 over 25. If I want the cosine of X, that's adjacent over hypotenuse, adjacent over hypotenuse, 7 over 25. And if I want tangent, it's opposite over adjacent, 24 over 7. Those are the values of the sine, the cosine, and tangent of that angle. Who's following so far? Well, if you're not paying attention, you're gonna be sorry. All right, now it says, what about angle y? Angle y, it's a whole new story. Now, I still have the same hypotenuse, but now I'm looking at angle y, I'm looking at this one. So which one is opposite relative to y? What's opposite relative to this angle? Really?
7.
Yeah, this is my opposite. And which one is adjacent relative to y? 2. Okay? So it's different now. So now when I want the sine of y, it's still opposite over hypotenuse, but it's this opposite over hypotenuse, 7 over 25. Cosine of y, adjacent over hypotenuse, 24 over 25. And then tangent of y, opposite over adjacent is 7 over 24. So they're different depending on the angle, so you have to be very clear what the angle is. Especially when you first start doing this, I think it's a good idea to label your sides so you don't mess it up. And then after a while you kind of get good at it. If you'll notice, look at this, the cosine of x equals the cosine of, or the sine of x equals the cosine of y. And the cosine of x equals the sine of y. And tangent of x is the reciprocal of tangent of y. So there are these different relationships floating around in here. We haven't really talked about the 90-degree angle. For now, it's something we memorize. We're not really going to explain it. Yes, you'll get this better explanation when you take trigonometry for reals in your pre-calculus or your class next year. The sine of 90 degrees is always 1. The cosine of 90 degrees is 0. And the tangent of 90 degrees is undefined.
Error. Divide by 0.
Undefined. And that is because, and you will learn this, tangent is sine over cosine. So 1 over 0, we can't do it. If you look here, sine over cosine, 24 25ths over 7 25ths is 24 over 7. Again, a little bit more advanced, and you will get there. But not, again, walk before we run. Okay, so now using the calculator, some of you already know how to do this, but here's something really, 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 really important. When you use the calculator has all these different ratios in it. Remember, it has it. We used to have big tables in the back of textbooks, and now we have calculators instead. When you use the calculator for trigonometry in this class, the first thing you do is, after you turn it on, is you're going to press the mode button. Okay, so see that mode button? It's right next to the second button. So press the mode button. No, not letting me do it. All right, let me try to see if I can fix this. Okay, sorry about that. Technology. Okay, so you press the mode button. These are all these different kind of settings that have to do with your calculator. So there's actually 2 ways, or more than one way, to measure degrees or angle openings. So I think we talked about this a little bit. There's something called the radian. And again, you're going to learn more about radian measures. It measures the arc opening pretty much, instead of this degree thing. But you'll learn about that when you take trigonometry in either altitude trig or pre-calculus. So I want degrees. The default for this calculator is radian, because once you learn about radians, you use that more. So, but I want degrees. So you kind of tab over there, and so this is lit, and press enter. It's up here. Okay, so degree. You have to be in degree mode, or you're going to get a mess. So first thing you should do when you turn on your calculator, and you're doing trig, press mode, and make sure you're in degree mode. Everybody's in degree mode? You've all checked? Yeah. It won't work well. You'll get a mess because you'll be working with radian. So very, very, extremely important. You will know, you will make this mistake. It's pretty much guaranteed. You learned this through Hard Knocks that I wasn't in degree mode, I got it all wrong. Okay. Now you choose your trig function. Let's say I want the sine. So where are those things? Where are they? Oh, here they are. So here's my numbers. Here's things like parentheses. Look up one. You see the sine, the cos, and the tan? These are abbreviations for sine, cosine, and tangent. So I'm going to put out here and just press sine. And then what do? You just, what do you want the sine of? So let's say I want the sine of 30 degrees. So you just put in a 30, and you press enter, you get a half. Sine of 30 is a half. That ratio, 30 degrees, in a right triangle, if you do the opposite over the hypotenuse, no matter what you get, it's always going to be a ratio of 1/2. Kind of cool. Okay, so that's just how you use the calculator. Just press buttons. You can force a degree mode. Now, if you're afraid you're one of these people that, I don't know, I'm not, what if I mess up mode? You can force it, see where it says, so you type in sine 30. So press in like sine 30. And then if you look at, I think it says apps down here, and above it it says angle. So it's the same color as your second key. So you're going to press the second key, and then where it says apps, so that it's, and it's going to say apps, and it gets you to angles. So I want degrees, so if you press enter, even if you're in radian mode, this will work as degrees. So it's just a way, if you really, really want to be sure I'm in degree mode, that you can force it. So this is more useful when you're using radians a lot, and you just every once in a while need to use degrees. So I just wanted to show you it was there, okay? So it will force degree mode even if you're not in degree mode. But be in degree mode. All right, so let's kind of do some examples here. Let's see, this looks like the bottom of page 1. So find x and y. Find x and y. Now I only have this one angle. Now you could say you have the other angle too, right? Can I find this other angle if I wanted to? Yeah. This one's 90, so these are going to be complementary, so I can do 90 minus 32 and get that angle. My advice is use what they give you whenever you can, because I will make a mistake sometimes doing something simple as doing 90 minus 32. I might put the wrong angle here, and then I'm working with something that's a mistake. So I'm going to use what they give me whenever possible. So relative to this angle, all right, first of all, the hypotenuse is always that one, right? Where's the opposite of 32? Where is that? Where is that at? X. And then the adjacent is the one next to it. So I can set up different ratios to solve this. So let me see what I got here. So the first step's find an acute angle that you know, set up the trig ratios, and use a calculator. So what do we got here? So if I want to find x, x is an opposite. Now you look at, I need to know something else. I could use tangent, opposite over adjacent, but that's x over y, two unknowns. That's not good. What about opposite over hypotenuse? That's sine, and I know this one. So you want to set it up that you only ever have one variable to solve for. And I should put SOHCAHTOA up here. So what I'm going to do is I'm going to say the sine of 32 degrees, right, equals opposite over hypotenuse. Opposite, which is the thing I don't know, over the hypotenuse, which is the thing I do know. So is this a correct ratio? Is this a sine of 32 opposite over hypotenuse? Yeah? Okay, I'm going to solve for x. How do you solve for x? Multiply both sides by 18. So x is going to be the 18 of sine of 32 degrees. Here's where my calculator comes into play. So 18 times the sine of 32 degrees. I'm in that mode of degrees, so I don't have to force the degree mode, which you can if you want. And then I'm going to go to the nearest hundredth, and what do I get? 9.54 approximately. And so that's x. Now they want me to find y, right? Find the other one. So I have more stuff here. So I don't know the adjacent. I know the hypotenuse for sure. I kind of know this, right? 9.54. So when I set up my ratio, what ratio should I use to find the missing y? What ratio should I use? Jack, what do you think?
Cosine.
Cosine. Why cosine?
Because 18 is a lot nicer than 9.54.
Okay, so what would this look like? Cosine of 32 equals what? Adjacent over hypotenuse. Okay, now I could have maybe done opposite, adjacent, opposite over adjacent, sorry, TOA. I could have done tangent. Now you're saying because this is not as nice as 18, I agree with you, 18 is a nice number to work with. Why else might I be hesitant of using the tangent? Yeah, what do you think? Yeah. So I could try and solve this. But what if I totally mess this up? What if I had the radians on or something? Who knows? I'm getting 2 wrong. Huh? And I round it, right? So it'll be a little bit off. But my advice, strong advice, is this is correct. There's nothing wrong. It's a correct ratio. Use sides that you know, that they gave you whenever possible. So I want to solve this for y. Again, multiply both sides by 18. You get 18 cosine of 32 And then I just put that in my calculator. 18 cosine of 32 is going to be approximately 15.26 if I press my buttons right. And now the question is, what if I didn't press the buttons right? Like, how do I know that this is kind of correct?
Faith in the buttons.
What?
Have faith in the
I
buttons.
have faith in the buttons. I don't want to use my fingers. That's what I don't have faith in. That I will sometimes press wrong things, and I do it all the time. I say, you know, I do these before, and I do them too. And I actually did this one wrong at first. I pressed something wrong. I knew it right away. How do I know? I used the Pythagorean theorem. I said, if this is right, this squared plus this squared should be that squared. Let's see if it is. So I did 9.54 squared plus, well, actually I took the square root of it. Let me take the square root because I want the actual side. So I'm using Pythagorean theorem. 15.26 squared plus 9.54 squared. This square plus this square, if you take the square root, you should get that side. And so that's going to be my test that I get the right measures. Well, I'm getting 17.996, pretty close, right? Why isn't it exact? Why isn't it exact, really? Because I rounded. So I don't expect to get exactly 18 if I did a little bit of rounding, but I'm pretty darn close. I have a pretty good feeling, okay, I probably did this right, probably. So do that quick check. We have a calculator, it takes a second, and it's like, okay, yep, I didn't mess it up. And I did, I messed it up the first time I did this when I was kind of working through the columns. So just check it takes a second. We have another example here on the bottom of page 1. Find x and y. Let's see what we got here. Find the, okay, x and y. So find the acute angle we know. 29, they're giving us 29. I can find angle C, but I'd rather use the one they give me. Set up the trig ratio. So let's see, if I want to find x. First of all, let's label what we got. This is hypotenuse, right? I know that. So relative to 29, who's the adjacent side? Where's the adjacent side here? Okay. Good. And then which was the opposite? Yeah, Amanda? 10. Okay, so let's see here. I want to find x. Which side do I know? 10. I have an opposite and a hypotenuse. Put our little mnemonic up here. So which trig ratio should I use, Ellie? Sine. So sine of this angle, 29 degrees, is going to be opposite over hypotenuse, 10 over x. So step 1, setting up that trig ratio. I think we got it. Now we have to solve it. And look, the x is on the bottom. And how you solve something like that? Yeah, Joseph? Why? It showed in the video. Just swap these two. How come I can do that? How come I can do that? Why can I do that?
What you do is you basically, if it's under x, first you multiply both sides by x. Cancel out the x, so now it's x sine 29 equals 10. And then you divide by sine 29. So that way it'll just be.
Perfect. It does switch. And if you think of this as proportions, remember we said you can swap these things? I think we proved that when we talked about proportions. You can swap means and you can swap extremes. So when you have a situation where the x is on the bottom, it is basically swapping them. But here's why. So if you forget, you can kind of get there again. So 10 over sine of 29, so 10 divided by sine of 29, I get approximately 20.63 to the nearest 10. If I didn't make a mistake, so that's x. And that's the hypotenuse, right? Did I do this completely wrong? Yes. Yes, I did. How come you guys didn't stop me? Oh, no, it's right. Okay. I think that's right. Okay. I got myself mixed up. Okay, so now let's look at sine of y. Okay, so y, now I could, if I wanted to, use hypotenuse, but again, I calculated this, and you can see how my mind is today. It's probably wrong, I don't know. My mind's like numb today. So I don't want to use something I came up with. So what do I have? If I want to find this value, which is adjacent, I know the opposite, they gave it to me. Which one works with opposite and adjacent? Tangent. So tangent of 29 is the opposite value, 10, over the adjacent, which is the y I'm trying to find. So when your y's in the bottom, that's a swapsy. So I can put the y here, 10 over tan 29. And let's see what we get. 10 over 10, 49, approximately 18.04. And, I'm a little confused today, so I hope I didn't make a mistake. But one way to kind of check it is, let me just use the Pythagorean theorem. So if I take the square root of a squared plus b squared, let's see, 18.04 squared plus 10 squared, that's easy at least, I should get around 20.63. Look at me. Pretty good. So even though my brain's a little bit fuzzy today, I still got it right. At least I can check it. So I really suggest just running through the Pythagorean theorem. Can't hurt, right? To know that, maybe you were in radian mode and you didn't realize it or something like that. I keep going back to that because guess what's a common mistake? You're in radian mode and not radian mode. Okay, so a couple of U tries here. Let's just see what's here. Yeah, go ahead. Just interrupt for 1 second. How are we doing across the top? Did we get A?
No, we're not done yet.
You're not done yet. All right, that's okay. But if you are done, if you got A, I've had some really great observations. One of them is yours, Amanda. She said, wait a second, this is 60, 30, 90 triangle. So if my hypotenuse is 12, what's side D going to be?
It's going to be
6 because it's half of 12, right? And then I can do 6 times the square root of 3. What's 6 times the square root of 3? 6 times the square root of 3 is 10.39, which is what we got. So the 60, 30, 90 triangle can be used here. Absolutely nothing wrong with it. I am asking you to use trigonometry here just for practice, but you are going to get the same thing. And Joseph, you noticed that this is a 45, 45 90. So that one has to be 6, and this one has to be 6 radical 2, right? And then if you do 6 radical 2, you get 8.485. That's kind of what we're getting here. So it does work either way, but I'm just having you do the trigonometry practice. There's an extra way for you to know that you're doing this correctly or not. I am going to ask you to maybe, if you only got one of them, maybe just look up for a minute because I want to just finish real quickly with this. So this one, you had actually draw a picture of a right triangle, and they gave you the sides. The biggest side is always your hypotenuse, right? So when I drew my triangle, I made sure that 17 was my hypotenuse. I should have put a right angle here. So that means these are legs. And angle X, it says, is opposite to the side of length 15. So there's 15, X should be here. If you put 15 here, your X would be there. Depends on how you draw the triangle. And angle Y is opposite the side that's 8. Angle Z opposite the hypotenuse, so that's your right angle. So being able to draw a picture relative to instructions is a pretty important skill. So yours might be a little different if you, it depends where you put your 15. If you put the 15 here and the 8 here and the 17 here, that's still Z, but I guess you have your X and your Y here. Either way is correct. And how do you find the trigonometric ratios? Sine of X is opposite over hypotenuse, 15 over 17. Now the sine of Y is also opposite of hypotenuse, 8 over 17. Cosine X adjacent over hypotenuse, adjacent over hypotenuse. Cosine Y adjacent over hypotenuse. So if you drew your picture correctly, you should be getting these values. Are there questions on this part? We're going to do a little bit of speeding through the next section. It's less important to us, more important to when you get to the next level of trig. Trigonometric values of special triangles. These are some of these things that when you get to trigonometry in Algebra 2 or in pre-calculus, you have to memorize this stuff. So to find the sine of 45 degrees, if you have this kind of triangle, so here's my hypotenuse. Doesn't matter which angles of these you pick because they're both the same. So I'm picking that one, opposite hypotenuse. Opposite over hypotenuse, 1 over square root 2. I want to rationalize that. I'm getting square root 2 over 2. Sine of 45 degrees is square root 2 over 2. Cosine of 45, well, adjacent over hypotenuse, same thing. That's also square root 2 over 2. And what's the tangent of 45 degrees? Opposite over adjacent is 1. So sine of 45 is square root 2 over 2. Cosine of 45 is square root 2 over 2. And the tangent of 45 is 1. Eventually, this is something you're going to have to memorize, but you can always draw this little triangle and get that. When you work with 30, 60, 90 triangles, I've got one set up here. So let's say I'm working with a 30-degree angle. Here's the opposite, here's the adjacent, and this is the hypotenuse. So sine of 30 is 1 over 2, which you saw that on our calculator. The cosine of 30 is adjacent over hypotenuse, square root 3 over 2. And the tangent is 1 over square root 3, which I need to rationalize. So it's square root 3 over 3. When we're working with the 60 now, using a different color now for the 60, that's my opposite, and that's my adjacent. So 60 is going to be opposite over hypotenuse, square root 3 over 2. The cosine is going to be adjacent over hypotenuse, and the opposite over the adjacent is going to be square root 3 over 1, which is square root 3. So these are ones that eventually you do have to know these by heart. So I wanted to introduce them to you so you can see them. And there's a little table I gave you of these values right here, including the 90-degree angles that someday you will have committed to memory. There is a bit of utrise here. The idea behind this was, can you do this using memorization? So I'm going to leave this for now. What I think I want to do is continue the rest of this next class. So you can copy these down if you want. We'll talk about them a little bit more next class.